Hey guys, welcome to the Athfix. In this video, I am going to discuss about the probability distribution. Before discussing about the probability distribution, we need to know about some of the topic. That includes the random variables, the probability distribution, and the cumulative distributive function. First of all, I will go with the random variables. What is exactly a random variable? It is a variable that takes up a different sorts of values to generate different outcomes from a random experiment. What is random experiment? Like throwing a die or flipping a coin. These are considered as a random experiment. Here we are given with a data table or a table. Here we have value as a 0. For that we have 1 by 4 and we have HH, HT, TH and TT. I will take the random experiment as a tossing two coins simultaneously. If I toss two coins simultaneously, then first I am going to get head, or I am going to get head tail, or I am going to get a tail head, or I am going to get a tail. These are the possible combinations that we have, right? And here we have the x equal to 0, 1, 2. X is a random variable. Now I am going to assign the value of x as getting total number of tails. Here we have the 0, getting total 0 tails in this particular experiment. There is only one possibility is head, in which there is no tail. Therefore in these all the four outcomes, there is only one such outcome where we have 0 tail. Now I will switch that x value to 1. Now getting only one tail from this particular experiment, right? Here we have only one tail and here we have only one tail, right? Therefore there are such two samples in which there is only one tail. Therefore we have 2 by 4, means out of 4 samples there are such two samples in which we have only one tail, and I am going to shift the x value to 2. Now getting two tails from this particular experiment, there is only one such value. Therefore we're gonna get 1 by 4, and this is what a random variable states. Random variable is x, in which we have the 0, 1, 2 that took different values, and we have generated different sorts of outcome. Here we got 1 by 4, here we got 2 by 4, and here we got 1 by 4, and this is what a random variable states. Here random experiment can be added as flipping the two coins simultaneously, and the different values are the values of tail as 0, 1, 2, and the different outcomes are 1 by 4, 2 by 4 and 1 by 4. You got it right, and this is how it goes. And the data or the variables are of two types: the discrete random variable and continuous random variable. What is exactly discrete and continuous? Here we got our values for 0, 1, 2 for getting 0 tails, getting 1 tail, getting 2 tails, right? If I change that and I want 0.5 tails in this particular experiment, no, I am not going to get any such thing like for 0.5 or 1.5, because these values don't exist, right? And here this is what we call as a discrete. For 0.5 we are not going to get anything. For any real number or for any decimal number, we are not gonna get any value, and that is what we call as a discrete random variable, a random variable that can take on a countable number of distinct values. Here we cannot consider 0.5 or 1.5. Therefore this particular experiment, here the values are also considered as discrete random variables. And in the continuous random variables, from minus infinity to plus infinity, you can consider any sort of a real number, you're gonna get the value. For example, we have the 7 billion population, and among 7 billion population, I want a person who is having the weight as 14 kg, or who is having the weight as 79 kg. I'm going to get those values, and those values are considered as continuous values, and for such we can able to do experimentation, and these are considered as continuous random variables, right? Now I'm going to discuss about the probability distribution. Probability distribution describes the probability of occurrence of each event for a possible values of random variable, or for the different intervals or different ranges of values. For example, In the before presentation only we had discussed that for 0 and for 1, for 2 we got different values, and these values are the distributions. For 0 we have 1 by 4 distribution, for 1 we have 2 by 4 distribution, for 2 we have 1 by 4 distribution. And add these all things. 1 by 4 plus 2 by 4 is 3 by 4, 3 by 4 plus 1 by 4 is 4 by 4. That means we got our value as 1, and this is what it states. And the probability distribution, the definition itself says that it describes all the probability of occurrence of different sorts of values for random variables such as 0, 1, 2, and our probability distributions are 1 by 4, 2 by 4 and 1 by 4. And this is what it states, right? And we have the PMF and the probability density function. This probability distribution is categorized into two types: the probability mass function and the probability density function. Here the probability mass function, when we add all the probability distribution, then we gonna get our value as 1. For previous example also we got our value as 1, right? And if you are adding the discrete random variables or or we are dealing with the discrete random variables, for example, as I previously discussed, the flipping coins, it is a experiment of discrete random variables. In such case we gonna use PMF, the probability mass function. If we are dealing with the continuous data, like we are dealing with the data of 7 billion population, that can be considered as continuous in nature, right? If you are dealing with the discrete random variables, then we gonna do summation to calculate the sum of all the values. If you are dealing with continuous, we gonna do the integration. Okay, here I am going to discuss that. We have the probability mass function, and for the x values, as I already discussed previously, x means the total number of tails, and this is flipping 2 coins simultaneously. We got our different values. This x is the random variable, these are the probability distribution, these are the outcomes, right? As I already discussed, probability mass function, if you do summation of these all things, 1 by 4, 2 by 4, 1 by 4, we're gonna get our value as 1. And this is what it states, means probability mass function, if you add all these values, then we're gonna get our value as 1. And in the density function, because the data is continuous means just think of it, processing 7 billion data and adding all the data, it is very complex process. Therefore normally what we do, we take a curve of that. For example, here we have some curve, it is a curve of e of x. If you add 1, 2, 3, 4 values, then we're gonna get the values like this. And this is the e of x, means this is a curve of e of x, and we're gonna do integration of e of x from minus infinity to infinity. Then we're gonna get our value, some value, and if you substitute over there, then we're gonna get our some values for that. And this is what we call as a probability density function. And we have the cumulative distributive function. I have previously discussed that for continuous random variables, we're gonna consider the probability density function for continuous, right? And here we're gonna add some limitations. Previously we have minus infinity to infinity as our limitation, but in the cumulative distributive function we're gonna add some limit. And if you add limit, then it is considered as a cumulative distributive function. Here also we are adding some limitation. P of x must be less than or equal to small x. Here also we are adding the summation must be from minus infinity to till x, right? And this is what we call as cumulative distributive function. And from this we gonna start the different topics like binomial distribution, normal distribution, uniform, multinomial, and Rayleigh, different varieties. Okay, let's summarize what we are discussing. We have discussed the probability random variables. Random variables are of two types, continuous and discrete. And the probability distribution for every random variable, there is a different outcome, and what we call as the probability distribution. And probability distribution are of two types. Means when we add all of the probability distribution, then we gonna get 1. And if we are dealing with the random discrete random variables, then we gonna consider PMF, probability mass function, for adding those all. If we are considering the continuous random variable, then we gonna consider probability density function. In the probability density function, we gonna use the integration. In the probability mass function, we gonna consider the summation. And in the cumulative distributive function, we gonna add some limit. And this is the summary of the presentation. Okay, thank you. Well, do subscribe our channel for regular updates. Thank you.